assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So in this problem, first we have to write down the solubility product reaction for the zinc hydroxide, and then we will have to write down the formation reaction for ZnOH for 2 minus, and then we will have to combine these two reaction equation to find the solubility of zinc hydroxide in the sodium hydroxide solution. So let's first write down our zinc hydroxide solubility reaction. This is a solid, and this is a reversible reaction, and we will have zinc 2 plus in aqueous condition with 2 hydroxide ions in aqueous condition, and the solubility product for this reaction is 3 times 10 to the power minus 17. Then we have to write down the formation of ZnOH for 2 minus, which is Zn2 plus in aqueous, and then we have to add 4 hydroxide ions to have the ZnOH for 2 minus in aqueous, and um, the formation constant for this reaction is 2 times 10 to the power 15. So now if we combine these two equation here, we can cross out these two Zn2 plus, and we have 2OH minus here and 4OH minus here. So if we just combine them, we can first write this one ZnOH 2 plus, we can subtract this one from this one to write down 2OH minus, this is a solid and this is aqueous, and then in the right hand side we'll have only this one ZnOH 4 2 minus, and the solubility constant for this, or the equilibrium constant for this reaction, will be K is equal to Ksp times Kf, that is these two constants here, and then if we just multiply them we will have a value of 0.06. Now we have to form an ice table for this reaction. So if we form the ice table, we have initial, let's find the initial concentrations, where for OH minus, let's write it a little bit lower. So for OH minus, and the initial concentration is 2 molar, and for the zinc tetrahydroxide, this has an initial concentration of 0. And then if we consider the molar solubility as S, in that case our change of the concentration here will be minus 2S, where S is the molar solubility which we are going to find out. And for this one our change will be plus S. So in case of the equilibrium, we will have 2 minus 2S, and here we will have S. So our equilibrium constant equation for this reaction, which is a value of 0.06, and we can equal this to ZnOH 4 2 minus, and the denominator we have OH minus square, and since we have a coefficient of 2 in hydroxide, we have to put a square on it. So why haven't we included the zinc hydroxide from here? Why haven't we included this? We haven't included this because this is a solid, and we know that the solid reactants, they actually, that does not they don't affect the equilibrium constant. That's why we don't include any pure solid or liquid in our equilibrium constant equation. So now if we just put the values up in the equation, we'll have it's equal to S, which is the equilibrium concentration for ZnOH for 2 minus, and for hydroxide ion we have 2 minus 2S square. Now solving this equation, we'll have two values of S, which is our molar solubility, which we are trying to calculate here. So it will have two values. One is 6 or 0.1667. So apparently this value is not possible if we just try to plug in it here. So our possible value here is this one. So that is our the solubility of zinc hydroxide in the sodium hydroxide solution. So if we just round it up to the significant figure, we can write it 0.17 m. That is our solubility of zinc hydroxide in 2 molar sodium hydroxide.